So our last criterion here is very similar to the monotonicity criterion, which essentially says that if options that shouldn't affect the winner are removed, they shouldn't affect the winner. That is, if a candidate wins an election and in a recount or a re-election, the only changes are that other candidates, that is, get removed from the ballot, then the original winner should still be the winner. Where to understand how this can happen, how we can end up getting that this fails, we'll take one more example. So for our example here, we have that 4 candidates are running to be the mayor of Salinas, with results shown by the table. And what we're going to do is use the pairwise comparison method to determine the winner. Then, note that prior to the announcement of the results, F and G withdraw from the election, where we're going to use pairwise comparisons again to determine who would win with them removed, and check to see if this violates the irrelevant alternatives criterion. So we're going to start here with 6 comparisons for our first step. It's going to be a little bit, because we have those 4 candidates. We need to compare each of them pairwise, got 6 options. For E versus F, 260 voters prefer E to F, while 100 prefer F to E, so E gets 1 point. Then for E versus G, 260 prefer E, so E gets that point. For E versus H, 200 prefer H to E, so H gets the point there. For F versus G, they're split evenly, 180 each, so they each get a half point. Then for F versus H, we have the 260 prefer F to H, so F gets the point there. And for G versus H, 260 prefer G to H, so G wins and will get that point. Which means that because of how all of these things get split out, and they're split out in quite a lot of ways, E wins with just 2 points. It's a very close election, really. You can see it's a pretty complicated little table in there. On the other hand, if we take this whole scenario and remove 2 candidates that should lose, that didn't do particularly well in that election, all we'd be left with is a comparison between E and H, where H was actually last in the original election, because F and G both had 1.5 points, while H only had 1. However, because E wasn't all that popular with voters other than their group of 160, with their plurality at the start, we would end up having that from our pairwise comparisons, H gets 200 of those possible votes. And so in this arrangement, we would have that H wins. And to say this doesn't affect E, to talk about that third step there, it's not quite fair in my opinion, because those were both a close second that we removed. But technically speaking, they were second place. And if you take first, remove second, and leave fourth, you'd think first would still win handily. If anything, it would be easier for first to win, but in this case, it doesn't work out that way. Last place makes a comeback because the people who didn't want E really didn't want E, so they get H instead and hope they're happy with H. Guess we have to wait and see. The last thing we're going to talk about here, it's a bit more loose. It's not going to be something that we're necessarily going to have homework problems on, really, but it's worth being aware of a result that came about in the 20th century discussing, well, why this sort of stuff happens with what's called Arrow's impossibility theorem.